So here R will depends on the dimensions. R is directly proportional to length. Idhar aa jao Saif. Idhar aake bait. R is directly proportional to length and then inversely proportional to area. And where the resistivity is just a proportionality constant only, that is known as the resistivity, and then it will depends only on the nature of the material. It does not depends on any dimensions of the material. That is what we are discussing about the R. And after that we have discussed the temperature dependency of the resistance. How it will depends on the temperature. What happens whenever you increase the temperature, then what happens? Resistance also increases. Why? Because length increases. If length is increasing means obviously resistance also increases. Now here after rising the temperature, let me take the temperature is changing from T1 to T2. Then the resistance is changing from R1 to R2. Then what we got? R2 is equals to R1 into 1 plus alpha into delta T. That delta T gives you T2 minus T1. So R2 is equals to R1 into 1 plus alpha into delta T. And after that, in this only temperature dependency is very important. In that only 5 types of formulas will be there, 5 types of problems will come. One is whenever you are increasing the temperature, at that time how the resistance changes. Final resistance will be what? Otherwise coefficient of expansion, coefficient of resistivity is what? That will be there, one kind of problem. Another problem is, I said already, whenever we connected in the series at 0 degree Celsius and connected in the series at the T degree Celsius, and both are having same effective resistance. At that time what we got formula? R1 alpha 1 is equals to minus R2 into alpha 2. That is another kind of problems. Another kind of problems is, I said already, I have given as a work for you, that is series and then parallel combination. That series combination is alpha effective for the series combination is R1 alpha 1 plus R2 alpha 2 by R1 plus R2. R1 alpha 1, I said R1 T1. Alpha 1, 2 different wires, right? Yes, correct. Next one is parallel combination. At parallel combination you will get R1 alpha 2, reverse you will get R1 alpha 2 plus R2 alpha 1 by R1 plus R2. That is for the series parallel combination. And one more set of problem will be there, that is R1 at temperature T1, R2 at temperature T2. Then what will be the alpha value? This one is different. This one is what? Whenever you rise the temperature, then it is changing. Whenever I select particularly R1 resistance at the T1 temperature and then R2 resistance at T2 temperature, then what will be the alpha value? That problem also will do. Okay, this kind of all the 4 cases will be there. One is whenever you are rising the temperature. Another is you take the effective series combination is equal for the final and then initial at all temperatures. That relation, what is the formula we got? R1 alpha 1 is equals to minus R2 into alpha 2. That is one more type of problems. Another is series parallel combination and then effective alpha value. And the next one is whenever I said only particularly R1 at temperature T1 and then R2 at temperature T2, then what is the alpha value will be? That will be one more kind of problem will be there. So if you learn these 5 types of problems in the temperature dependency, everything will be finished. But you have to identify mainly when you have to use which formula. Okay, by practicing the problems you can understand that. First of all, write a problem. Conductivity I said, right, already? Conductivity is finished, na? Write that. Resistance of a wire is R1. Resistance of a wire is R1 at temperature T1. R1 at temperature T1 and R2 at temperature T2. And whose thermal coefficient of resistance is alpha. Whose thermal coefficient of resistance is alpha. Then find alpha. Try that once. Temperature, same temperature only. Temperature same I said. At T1 I said, no? At T1 and then T2 I said. Temperature is different only. R1 at T1, R2 at T2. You have answer you are asking. Yes, you are in terms of T only. Manta answer? That already first form whenever the temperature is rising at that time, that one I am specifying the temperatures here 0 to 30 degrees and ಕೊಟ್ಟಿದೆ ಅಂದರೆ ಆ ಥರ ಮಾಡಬೇಕು. ಅರ್ಥ ಆಯ್ತಾ? ಇನಿಷಿಯಲ್ ವ್ಯಾಲ್ಯೂ ಬಗ್ಗೆ ಏನಾನ ಕೊಟ್ಟಿದ್ದೀನ ಅದು ನೋಡು ಫಸ್ಟು, ಅಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. Very good, very good. That's the correct answer. R2 minus R1 I think you have to get. R1 minus R2. R2 minus R1 by R1 T2 minus R2 T1. You got that? How many of you? Very good girls. R2 minus R1 by R1 T2 minus R2 T1. That's the answer. Alpha is equals to R2 minus R1 by R1 T2 minus R2 T1. This is the answer. See that? Look at the board. Specially I mentioned that at temperature T1 what is the resistance? R1. At temperature T2 what is the resistance? R2 is the resistance. Then I am asking to find out the alpha value. For that, first of all, here whenever you see the first case, whatever the first case we are having, alpha is equals to what is the formula for us? Delta R by R into delta alpha into delta T. Alpha into delta T, R into delta T. Delta R by R into delta T is the alpha. When you have to take this one means you have to take whenever the temperature is rising from T1 to T2. Rising from T1 to T2 and the resistance I said R1 to R2. Then you have to take this formula. Now what I am saying, particularly at T1 temperature resistance is R1, particularly at T2 temperature resistance is R2. Then you have to find out the alpha value. This case and then that case both are so much difference is there. Here increasing temperature, they are talking about the delta T. Here I am mentioning the temperatures. Clear? Now I did not know the initial value first of all. I said only the resistance of a wire is R1 at temperature T1 degree Celsius. R2 at temperature T2 degree Celsius. Did I mention about any initial resistance? But here from where you will start? 0 degrees you will start. 0 is the initial temperature you will take. R0 is the initial temperature you will take. So here I am not raising the temperature. I am mentioning about at particularly let me take 30 degrees Celsius we are having 100 ohms of resistance. After that how much ever I increase. For example, let me take at 50 degrees Celsius I have 150 ohms of resistance. That is how I am saying. I am not saying that whenever you are raising the temperature from 30 to 50, resistance is changing like this. Both are different. Here initial resistance is not necessary here. I don't know initial resistance also. For that, first of all let me take at the initial resistance is R0. R0 will be at what degree Celsius? 0 degree Celsius. Now from that initial resistance only, whenever I take the temperature as T1 degree Celsius, I am getting the resistance as how much? R1. And if I take the temperature as T2 degree Celsius, then resistance how much we are getting? R2. Now tell me, take this first of all this case and then take this case later. First of all this case, whenever you see R1 is equals to what I can write? Tell me now. R1 is equals to only this case. R naught into 1 plus alpha into delta T is how much? T1 minus 0, that is T1 only. Finished. First case is finished. Next case. R2 is equals to, again R2 is equals to this case, only this one. R2 is equals to R naught into 1 plus alpha into T2 minus 0. Correct? So that R naught into 1 plus alpha T2 minus 0 is T2 only. Then what happens here? R naught gets cancelled. Then R1 by R2 is there. Now you do the cross multiplication here. When you do the cross multiplication, what will you get here? R1 plus R1 alpha T2 is equals to R2 plus R2 alpha T1. Then here we want to find out the alpha, means R1 alpha T2 minus R2 alpha T1 is equals to R2 minus R1. Then alpha is common here. Then what will you get? Simply R1 T2 minus R2 T1 is equals to R2 minus R1. Then alpha is equals to R2 minus R1 by R1 T2 minus R2 T1. This is the answer for that. Anyhow you can get, even you can get it as R1 minus R2 by R2 T1 minus R1 T2. Anything is correct only. Anything is okay. Minus gets cancelled however. Now the thing is, you have to make the differentiation between this formula and then that formula. That is important. Mainly identify that whenever they said that whenever the temperature is rising from so and so value, at that time immediately you have to use this one. Whenever they said that at particular temperature resistance is R1, at another particular resistance the temperature the resistance is R2, then find out the alpha value, means you have to use this formula. So initial resistance we don't know, so only I cancel the initial resistance here. So at R0 at 0 degree Celsius I am taking the resistance as R0. From that at T degree Celsius same wire only we are taking again, same wire resistance we are increasing here. So that at T1 degree Celsius resistance is R1. Take this as one case. The resistance is changing from where to where? R0 to R1. Temperature is changing from 0 to T1. That is what I have written first case. Then second one, again at T2 degree Celsius I have another resistance, that is how much? R2. Now temperature is changing from 0 to T2 and the resistance is changing from R0 to R2. And then I just divided them and then cancelled everything, and then we got the final answer. Here even you can get the answer as R1 minus R2 by R2 T1 minus R1 T2 also. Everything is correct only. Clear? Yes, copy that. I will give all the formulas at a time as a note point, then you can identify when to use which formula. You are sitting in front of the fan for that much time means you will get dehydrated. Dehydration adike kan mante agtadilla. It's burning, right? Note point. Very important. ಶ್ರೀವಲ್ಲಿ ಬಗ್ಗೆ ಡ್ರೀಮ್ಸ್ ಜಾಸ್ತಿ ಬಂದಿದೆ. ಮದುವೆ ಡೇನಾ ಇವತ್ತು? ಶ್ರೀವಲ್ಲಿಗೆ ಮದುವೆ ಆಗ್ತಾ ಇದೆ. ಯಾರ ಜೊತೆ? ಯಾರೋ ಒಬ್ರು, ಇವರಿಲ್ಲ ಅವ್ರು ಹೋಗಿದ್ರು ಅನಿಸುತ್ತೆ. ರೈಟ್ ದ ನೋಟ್ ಪಾಯಿಂಟ್. ಟೆಂಪರೇಚರ್ ಎಫೆಕ್ಟ್ ಆನ್ ರೆಸಿಸ್ಟೆನ್ಸ್. First formula, first one. If temperature changing from T1 to T2, if temperature changing from T1 to T2 and resistance changing from R1 to R2, resistance changing from R1 to R2, then R2 is equals to R1 into 1 plus alpha into delta T. In the place of delta T, T2 minus T1 you write. Then alpha is equals to what I can write simply? delta R by R1 into delta T. That is the alpha value for that. Then second formula. Particularly resistances are given at specific temperatures, then what is the formula? Alpha is equals to how much? What you will get at R1 at T1 at the moment R2 minus R1 by R1 T2 minus R2 T1. See that always remember, for this I will tell you one trick to remember. Here 2 coming nothing but here 1 will come. You have to remember that, otherwise you will get wrong answer there. So here 2 coming nothing but here you have to take it as 1. Why? Because if you take it as a 2 at that time what will you get? Negative answer you will get. Otherwise if you take both are same only R1 T1 R2 T2, if you take means you will get wrong answer only directly. So that take that properly. Otherwise you can either take that as R1 minus R2 by R2 T1 minus R1 T2. Anything you can take. Then next one, third formula. The condition for effective resistance is same as previous at all temperatures. What is the formula? R1 alpha 1 is equals to minus R2 alpha 2. R1 alpha 1 is equals to minus R2 alpha 2. Next, third one. Resistances are in series. Of different materials. Then write these two formulas. Series and parallel. You are not able to see that? Alpha series, write that. Alpha series equals to R1 alpha 1 plus R2 alpha 2 by R1 plus R2. Alpha parallel. R1 alpha 2 minus R2 alpha 1 by R1 plus R2. Plus or plus minus? Plus. Everybody has written as plus and then he is writing as minus. ಇವತ್ತು ವೆದರ್ ಚೆನ್ನಾಗಿಲ್ಲ ಹೌದಲ್ಲ? ವೆದರ್ ಇಸ್ ನಾಟ್ ನೈಸ್ ಟುಡೇ. ಡೈಲಿ ಇಟ್ ವಿಲ್ ನಾಟ್ ಬಿ ನೈಸ್. ಹಾಲಿಡೇ ಅಲ್ಲ, ಹಾಲಿಡೇ ಮೋಡಲ್ಲಿದ್ದಾರೆ ಎಲ್ಲರೂ. ಹಾಲಿಡೇ ಇದೆ ಅಂದರೆ ಕೂಡ ನಿಮ್ಮ ಹಾಸ್ಟೆಲ್ ಅವ್ರಿಗೆ ಏನಿರಲ್ಲ. ಡೋಂಟ್ ವರಿ ಅಬೌಟ್ ದಟ್. ಆ ಸಿಲ್ವರ್ ವಯರ್ ಬರ್ತೀನಿ, ನಾನೇ ಬರ್ತೀನಿ ಅಲ್ಲಿ. A silver wire has a resistance of 2.1 ohms. A silver wire has a resistance of 2.1 ohms at 27.5 degrees Celsius. At 27.5 degrees Celsius and 2.7 ohms at 100 degrees Celsius. Then determine temperature coefficient of resistivity. Determine temperature coefficient of resistivity. One more problem you write. Meanwhile, I will drink tea and then I will come. One more problem. Barry, yaar gonna bekandre barry. The temperature coefficient of resistance of platinum. The temperature coefficient of resistance of platinum is alpha is equals to 3.92 into 10 power minus 3 per Kelvin. 3.92 into 10 power minus 3 per Kelvin at 0 degree Celsius. Then find the temperature at which the increase in resistance of platinum wire is 10% of its value at 0 degree Celsius. 10% of its value at 0 degree Celsius. Increase in the platinum value nothing but the R2 value they are asking. How much R2 value they are giving? R by 10. 10% of the initial value. That's it. R2 is equals to R1 by 10. So normally only delta T value you have to find out. Delta T is equals to, what is the formula for us from here? Delta T is equals to delta R by R into alpha. So here delta R nothing but R2 minus R1 by R1 into alpha. What is this R2 value? R2 value is 10% of R1. 10% of R1 nothing but how much you will get? R2 is equals to 10 by 100 of R1. And then this value becomes how much here? R1 by 10. R1 by 10. Otherwise 0. R1. That is increase in otherwise final value they are giving. Increase under delta nedu, just the delta only. This is just delta only. The rise is how much? Nothing but 0.1% of R1. They are saying that, see this is wrong. Final value is different. Final value is R2 is equals to R1 plus delta R. Correct? R2 minus R1 is equals to delta R. And then R2 is equals to R1 plus delta R. See that I thought that is final value. Where is the duster? Now increase in the resistance E is they are saying that as 10%. Increase in resistance but only change that giving about. Delta R is equals to 10 by 100 of 10% of the initial resistance R1. So that 10 by 100 of R1 is a delta R. Then this will be how much? R1 by 10. This is a delta R. Delta R meaning is what? R2 minus R1. R2 minus R1 is equals to R1 by 10. Then R2 is equals to how much you will get? R1 by 10 plus R1. And by the way, for us only delta R is needed. R2 minus R1 nothing but what you have to take? Delta R only. There is no need to find R2 value also. There is no need to do this much also. Just directly you can take this one. R1 by 10. Directly you will get here. See that? This one is what here? R2 minus R1 nothing but delta R by R1 into alpha. Delta R is how much I said? 10% of R1. Nothing but how much you got? R1 by 10. So R1 by 10 that will get cancelled however. And then R1 into alpha. R1 gets cancelled. Then what will get? 1 by 10 alpha. That is the answer. 1 by 10 alpha is the correct answer. Look at that. For us, delta T is delta R by R1 into alpha at 0 degree Celsius, at 100 degree Celsius, whatever it might be. Alpha is same only however. Alpha value they have given and they are saying that increase in the resistance is 10%. So that 10% you have to take nothing but that is how much? 10% of R1. Increase nothing but you have to take delta only, not the final value. Final value is different, increase is different. I said already increased by and then increased to. What is the meaning of increased by? Change or final? Change. Increased by means change. Increased to means final value. Clear? So here also they are saying that increased by, nothing but change in percentage. So delta R is equals to 10% of R1, 10 by 100 of R1, then delta R equals to R1 by 10. Unnecessarily don't find the R2. Why? Because there is no need to substitute only. Directly we will get that. Delta R is equals to R1 by 10 divided by R1 alpha. 1 by 10 alpha is the answer. Substitute the alpha value, you will get the answer. You got that? How much? 25.51 degrees Celsius. Substitute the T1 value and then T2. T1 is how much? 0 degrees Celsius only. Yes, directly T2 you will get. That is about the resistance problem. One more thing. One more. Little lengthy. Like that. A heating element using nichrome. A heating element using nichrome connected to a 230 volts supply. Connected to a 230 volt supply draws an initial current of 3.2 amperes which settles after a few seconds to a steady state value of 2.8 amperes full stop. What is the steady temperature of the heating element if the room temperature is 27 degrees Celsius. Room temperature is 27 degrees Celsius. By the temperature coefficient of resistance of nichrome is 1.7 into 10 power minus 4. 1.7 into 10 power minus 4 per degree Celsius. Read the question. If you want, I'll explain that briefly. First of all, read the question. They are talking about which formula. First of all, you have to understand. First formula na second formula na. Enta? Deniki? Ida 0.039. Question 230 3.2 and 2.8 tarvata. Where is Girish? Headache. Which formula? Tell me first of all. First one or second one? Which formula you have to use? See that they are giving at room temperature, at steady temperature. At room temperature, at steady temperature, but at T1 at T2. Which formula you have to use? Second formula, R2 minus R1 by R1 T2 minus R2 T1. That is about the alpha. But they are not asking about the alpha here. They are not asking about the alpha, right? They are asking about the temperature. You have to use that case only. Shall I do that? Little lengthy calculation will be there. You got the answer? 867 degrees Celsius is the correct answer. You got that? Approximately. See that? Look at the board. A heating element using nichrome, nothing but whatever they have given a wire, that's it, connected to 230 volts supply draws an initial current of how much? 3.2. First of all, initially they said that it is connected to how much voltage? V is equals to 230 volts. At that time it is drawing how much current? I is equals to 3.2 amperes. And after that 3.2 amperes which settles after few seconds to a steady state value of 2.8 amperes. Nothing but initial current was this one. Steady state current was how much? I is equals to again I2 is equals to how much they said? 2.8 amperes. Don't worry about that one, that is just for the resistance only, that's it. Then after that, what is the steady temperature of the heating element of at room temperature is how much? 27 degrees Celsius. Room temperature, let me take first of all initial one is 27 degrees Celsius. Then you have to find out the steady temperature, let me take T2. T2 you have to find out, and then alpha is how much they have given as 1.7 into 10 power how much? -4 per degree Celsius. This is what the question given. Look at that first. Understand the question. Now, a nichrome material is connected to the voltage of how much voltage? 230 volts. At what temperature? At what temperature? Room temperature. Room temperature 27 degrees Celsius. Then it is drawing how much current? Nothing but 3.2 amperes. Then after that, it is coming to the steady state. It is coming to the steady state. That steady temperature only I don't know. T2 value I don't know. But the voltage is same only initially, finally. And then current is changing as how much? 2.8 amperes. Nothing but indirectly they have given about the R1 and then R2. R1 at 27 degrees Celsius, R2 at so and so temperature, so that I can get the alpha value as this much. That is the question, given question is. So R1 at room temperature, R1 is equals to what we get here? R1 is equals to, what is the formula? V is equals to IR, R is equals to V by I. V is how much here? 230, R is equals to V by I. You have to use 230 divided by 3.2. Keep it as it is. Why? Because here 3.2 is there, here 2.8 is there. So that this can be go with the 4 sevens and then 4 eights. There is no need to cancel anything here. Now 230 by 3.2, that is about the R2. Next one is R1. I'm sorry. Next one is R2. You have to find out. R2. This is at what temperature? At what temperature? Room temperature 27 degrees Celsius. At so and so temperature, I don't know that. That is T2 degrees Celsius. We are getting the R2. R2 is equals to again voltage by current only. Voltage is how much here? 230. 230 by current is how much? 2.8 amperes. That is R1 and then R2. R1 at 27 degrees Celsius, R2 at T2 degrees Celsius. What is the formula you have to use? Obviously, alpha is equals to R2 minus R1 by R1 T2 minus R2 T1. But there you have to multiply with the resistors later, so that it will make complicated calculation. Before that, instead of that, what will you use? Nothing but we will use the derivation only. What is the derivation we have taken? First, which case we have taken? 0 to T1. Another case is 0 to T2 we have taken, and then we got the two equations. After that, we have divided them and then we got the answer. In the same way, here also we will do. That is R1 is equals to what I can write? R0 into 1 plus alpha into T1. That divided by R2 is equals to what I can get? R0 into 1 plus alpha into T2. That is the basic derivation we got. Now R0 gets cancelled. Why? Because we don't know anything about that. Then R1 at what temperature? 27 degrees Celsius. Take the R1 value, that is how much? 230 by 3.2. Then R2 is 230 by how much? That is 2.8. Directly we can cancel it. That is equals to 1 plus alpha value you have to substitute, and then T1 is how much? 27 degrees Celsius. That divided by 1 plus alpha, and then T2 is you have to find out. This will go, and then how many times it will go? This is 4 8s and then 7s. Nothing but you will get 7 by 8. Cross multiplication will be easy. 7 by 8 is equals to 1 plus alpha into 27 by 1 plus alpha into T2. Find out the answer. Alpha value you have to get. You'll get it as 897, I guess. 867. Yes, you got that? Something doubt is there in your face. Approximately. $897, 67 birthday. Approximately you can get, there is no problem. Approximately 850 like that you can get. You understand the question right first? At room temperature only, but they are not giving the resistances, they are giving the voltage and then current. By that you have to find out. At T1 temperature, that is room temperature, and the resistance is voltage by current, initial current, and then voltage by final current gives you R2. At T2 temperature, that T2 only you have to find out. 867 is the correct answer. See, so don't leave the calculation. In the exam, by the way, you only have to do. I can leave and then I can stop here only. Nothing will happen to me, and then I can say to you directly answer, but you have to calculate. There only your speed will increase. Finished, huh? The next one is special cases for the resistance. Already we know the basic formula of the resistance. What is that? R is equals to rho L by A. Now from this what I can write means, already we have written already in the morning only, that is R is directly proportional to L and then R is inversely proportional to area. Instead of area what I can write? Inversely proportional to square of the resistance, R square I can take. From that we got the relation that R1 by R2, otherwise R2 by R1 is equals to L1 by L2, and then here R1 by R2 is equals to how much we got? R2 square by R1 square we got. And also from that I said the change in the resistance also. What is that? Delta R by R is equals to delta L by L directly, and then delta R by R here is equals to how much, that is 2 into delta R by R. Minus you will get, why? Because whenever the area is increasing at that time resistance will decreases. Why? Because both are inversely proportional to each other. These are the cases we have seen, and this will applicable when the fractional change will applicable when the percentage change is less than 5. Whenever it is less than 5, do you remember that? I have said so many times in the percentage problems. This methodology will be applicable only at the percentage change is less than 5. If it is more than 5, then what you have to do? Nothing but how to find out the percentage change, I will tell you. So R1 by R2, for this one directly only it will come, directly same only it will come. R1 by R2 is equals to L1 by L2. And here you have to get the percentage change, means take here minus 1 and then here also minus 1. Listen, this is a trick. So here R1 by R2 and then is directly proportional to what we got here, L1 by L2. Whenever the percentage change is greater than 5, for example length is changing as 50% or 20% like that, then how to do the fractional change in the resistance? That is what I am saying. If the length is changing 32%, let us consider. Length is changing 32% of the initial value, then find the fractional change in the resistance. At that time if you do directly delta R by R is equals to delta L by L, for this one there is no powers, directly you will get the answer correctly only, but for this one it will be wrong. If the radius is changing as 30% At that time you have to find out the fractional change in the resistance. If you do 2 into 30, your answer will be wrong. You understand? So always whenever the percentage change is less than 5, at that time directly fractional values you have to apply in the errors method. If not, you have to do in the kinetic energy method. I said one kinetic energy loss in the work power energy in the collisions, I guess so I said. So that one you have to follow. You have to take final minus initial by initial. Instead of that, direct relation only will take R1 by R2 is equals to L1 by L2. For that, what I will do, nothing but I will just do minus 1 here, minus 1 here. Then what will get here? If I take the LCM, R1 minus R2 by R2, that is equals to L1 minus L2 by L2. That is what you have to do. Clear? Then after that, whenever resistance they are talking about, resistance change is less than 5, directly delta R by R is equals to 2 into delta R by R only we will write. Then if R is changing more than 5%, the percentage change is more than 5%, then what you have to get, nothing but simply take final by initial you have to take, I think. Yeah, R2 by R1, and then here only you have to get initial values, right? Nobody said that. Divide by initial value only, right? You have to get. What, Yavaraja? You was looking like that only, but you did not say anything. Correct, huh? Delta R by R. That will be, if that is minus means you are getting the initial value is greater than the, final value is greater than the initial value. If you are getting in positive, nothing but your final value only greater than the initial value. Okay. Now in this, if the percentage change is greater than 5, then what we get here means directly write R2 by R1 is equals to, what I can write here, R2 by R1 is equals to R1 square by R2 square. Now for this what you have to do? Minus 1 you have to do. So that minus 1, here also minus 1. Then what we get here? R2 minus R1 by R1, nothing but delta R by R is equals to, what we get here? R1 square minus R2 square by R1 square, R2 square. Why we are getting R2 square in the denominator? Inversely proportional there. Clear? So this is what you have to do, R1 square minus R2 square by R2 square. This is how you have to do the percentage change in problems, if that is a greater than 5 or less than 5. Clear? I think you have copied this one. At the same place you just copy this one also. No need to do this final answer also. Directly you just do minus 1, that's it. Both the sides minus 1. Are you okay, Pavitra? You okay? Yes. Any problem? No. Drink some water, no? Drink some water. Finished? Now, whenever the wire is twisted, stretched, twisted and elongated and drawn. So, in this all the cases what happens? Whenever I stretch the wire, otherwise I fold the wire, otherwise I just draw it, otherwise I just elongate it, twist it, what happens? I am not asking about the resistance, what happens to the resistance or what happens to the volume. Same only, volume remains constant only, there is no change in the volume. However, length is increasing, nothing but diameter will decreases, again same only. Whenever you are compressing, at that time what happens? Length decreases, diameter increases. Again volume is same only. Whatever you do for the wire, always volume remains constant until unless if you are adding impurities, at that time the volume will changes. Obviously volume and then density changes. But here you are not doing anything from the extra, and then you are just twisting it, otherwise elongating, stretching, whatever you might be do, but the volume remains always constant only. You might be getting that doubt that why length will increases, right? How the volume remains constant. Length increases, but what happens to the radius? It will become thinner. Length is increasing, radius is decreasing. Again same only, balancing only, compensating that side and then this side. And then whenever you are just compressing, at that time what happens? Length decreases, but what happens? Area will increases. Again the same value only will get. So always whatever you do all these operations, at that time volume is constant. Volume is constant. Whenever the volume is constant and you have to get the relation between the resistance and then length and then resistance and then area, you have to do that, means you have to get the volume in your formula. In the solids also I said the same trick only. Whichever you want to keep the constant, that should be there in your formula. If it is not there, you have to get it and then make it to constant. That is what the trick I said in the solids also. Here also, what is our formula? Resistance is equals to rho L by A. Now I want to find the length and then resistance relation. So directly R is directly proportional to L means that's wrong. Why? Because here which one is constant? Volume is constant. So your formula should have the volume. That's compulsory. So that what I can do here? What I can do? Multiply L and then divide by L. You can even do the multiply by A and then divide by A. But area is also variable, length also variable. I want only which relation here? L and R relation only. Otherwise, most of the people might be immediately think that I will just multiply and then divide by A. Then L into A means I will get the volume. Yes, you will get the volume. But what is the relation you are getting? Area relation. Area and then resistance relation. Which relation you have to get here? Length relation. So that you want to keep the length as it is, so that L and then L I will do here. Then area into length gives you what? Volume. And then rho is constant, volume is constant. Then R is directly proportional to L square. But here R is directly proportional to L. How to find out the difference? How to find out the difference? They will not mention volume is, they will never mention volume is constant. They will just mention these words in the problem. That's important. Stretched, twisted, or elongating, compressing, drawing, whatever they are doing, volume remains always constant only. You just forget about the shape. Shape will changes, but volume is same only. Now, in that cases only you have to use this relation. Otherwise, they said that initial value and then first value and then second wire, first wire and then third wire, like that means you have to use these relations. Clear? Now, this is R is directly proportional to, R is equals to what I can write? Rho L square by volume. Then R is directly proportional to L square. Now, what I can write here? Delta R by R is equals to how much you will get? Delta R by R is equals to 2 into delta L by L. For which case this is? At what value of percentage change? Less than 5. That's important. Less than 5. If the percentage change is less than 5, then you have to use delta R by R is equals to 2 into delta L by L. I can write even it as R1 by R2 is equals to L1 square by L2 square. Now, if the percentage change is greater than 5, then what you have to do? R2 by R1 is equals to L2 square by L1 square. Then what you have to do here? Minus 1 simply. Minus 1, minus 1. Then you will get the answer it as delta R by R1 is equals to, what will you get here? L2 square minus L1 square by L1 square. That is the answer whenever the percentage change is greater than 5. Now I want to get the resistance and then area relation. What is that resistance and then area relation? Resistance area relation. And then I want to keep the volume is constant. Same case only again I am doing. What will get here? R is equals to rho L by A. I don't want to get to the L now. What I have to do? Into A divided by A. Then L into A becomes what? Volume. So that rho V by A square. Then R is inversely proportional to A square and also inversely proportional to R power 4. anything is correct only. Then now R2 by R1 is equals to what I can write, A1 square by A2 square is equals to R1 power 4 by R2 power 4. That is what you will get in terms of radius and then area. Now percentage change, if it is less than 5%, then what will get, delta R by R is equals to what I can write simply, plus 2 na minus 2 na, minus 2 into delta A by A, and also minus 4 into delta R by R. So minus 4 into delta R by R. That is the percentage change is less than 5. If it is greater than 5, R2 by R1 is equals to A1 square by A2 square. What you have to do here? Minus 1 is equals to minus 1. Then you will get directly delta R by R1 is equals to A1 square minus A2 square by A2 square. So this and all is not necessary to do. Don't do the squares and all. Directly find the ratio and then do minus 1. That's it. Your answer will be finished. This ratio, if you get the 4 means 4 minus 1, 3% is the answer for the percentage change in resistance. 3% means it will not come here, by the way. Then next one is, in terms of radius, if I get R2 by R1 is equals to how much you will get? R2 by R1 minus 1 is equals to R1 power 4 by R2 power 4 minus 1. This is the delta R by R. Clear, right? You understand all? So stretching, twisting, elongating, compressing, drawing. Whenever they use this kind of words, always you have to remember that R is directly proportional to L square and also R is inversely proportional to A square. Whenever they said one wire is having the length L1, another wire is having the length L2 and then radius R1, radius R2 means you have to take directly R is directly proportional to L and then R is inversely proportional to A. Be careful, I explained very clearly, don't give a chance for the negative marking in this. Why? Because if it, instead of taking that relation, if you take this relation, your answer will be wrong. Why? Because you will have two options in that. Understand, right? Copy that. This one is finished, huh? This one, first one. Then write as a note point. When the wire stretched, comma elongated, comma compressed, comma twisted or drawn, then volume remains constant. In the side you write as a trick. If we keep any component as a constant, that should be present in the formula. This is very, very important. You have to remember always. So here volume is constant. So in this case volume is constant. Then rearrange the formula in terms of volume. When you have to use these formulas, 2 wires are given. When 2 wires are given, that is about the single wire. Clear? Mention that also, otherwise you will get confused why we have to use that formula, this formula and all. If 2 wires are given, ఒక నోట్ పాయింట్ చెప్తా, రాసుకో, రేపు కంబైన్డ్గా చెప్పాలి, రాసుకొని చెప్తా. పర్సెంటేజ్ చేంజ్ లెస్ దాన్ 5 ఎర్రర్స్ మెథడ్, more than 5, next line, more than 5, fractional loss, fractional change. రేపు గుర్తు చేయి, అందరికీ చెప్తా కంబైన్గా, మళ్ళీ వాళ్ళకి మిస్ అవుతుంది, మీకే చెప్తా. క్లియరా? సో ఆల్వేస్ యూ హ్యావ్ టు రిమెంబర్ వెనెవర్ యూ సీ ఎనీ పర్సెంటేజ్, immediately you have to remember these these formulas, not only this here. I am talking about any percentage change in any chapter. Always if the percentage change is less than 5 means you have to use the errors powers method. Otherwise whenever the percentage change is more than 5, at that time what you have to do, you have to take the fractional change method, that is just -1 only. From the relation will be there, whatever the relation is there, take the ratio of relations, just put -1 for that, that's it, you will get the answer. Clear, right? You have to remember that always. Then next one is, in the case of conductor of length L of area A, what is the resistance? In the case of a wire of length L and then area is A, then what is the resistance? R is equals to how much? Rho L by A. So first one is wire, if I consider that wire of length L and then area A, then R is equals to, obviously resistivity is rho here, rho L by A. That is, everybody know that already. Now if I consider the same wire as a cylinder which is having inner and then outer radii differently, if I take the inner radii differently and then outer radii differently, then what will you get? Resistance, inner radius is here R1 and then outer radius is R2. So what will you get? R is equals to rho into length is obviously L only, rho L by area of this one is how much? Pi into R2 square minus R1 square. Anytime there will be concentric, one in the other means always you have to get the same thing only. If that is about the spheres, concentric spheres, 4 pi R2 square minus R1 square, we have already taken in the fluids chapter. Yes sir. So here also pi into R2 square minus R1 square, that is about the cylindrical wire which is having the radius, inner radius and then outer radius. And then for example, if I now consider, observe properly this one, cube. If I consider cube of side A, cube of side A I considered, this is A here. Now you have to find out the resistance along each, perpendicular to each face. Let me take, this is R1, R2 and then along the breadth it is R3. And also one thing is, here whenever you consider R is equals to rho L by A, the current is passing through this wire. Nothing but you have to take the length along, current along the length and also current perpendicular to the area. In this direction current is coming. Always current flow will be in which direction? Nothing but along the length only, along the length of the wire only. and it will come out, how it will come out, nothing but perpendicular to the area only. This is the perpendicular to area. In the same way here also you have to apply. What is the answer you will get? R1 is equals to, find out the R1 separately. R1 is equals to what you get? By observing only you can tell the answer. There is no need to do with a pen. Rho into, okay. R1 is covering how much length? A length only, right? A length, that divided by, from which area it is coming out? This area, right? What you have to take that as? A square, that's it, finished. Then A square, A gets cancelled. What will you get here? Rho by A. Then what is what about R2? R2 is equals to also same only. It is covering how much length here? A length, and then coming out of which area here? A square area only. So that again rho by A only. Then R3 also the same only, rho by A. Front to back. R3 is coming as front to back. Then next one is cuboid. If I consider the rectangular block, otherwise cuboid. Like this I considered, of length L, breadth B, and then height H. Now you have to find out the R1 and then R2 and then R3. Can you tell me that? By seeing only, can you tell me? R1, R2 and then R3. How much? First of all, take length and then area correctly. So, first one, R1 is covering how much length? L length, right? R1 is this one. R1 is covering how much length here? L length. So that rho L divided by, from which area it is coming out? See that from this area it is coming out. What is the area of this one? B into H. Clear? So that rho L by BH. I will tell you the short trick to remember also. So then next one is R2. R2 is going in this direction. So how much distance it is covering? H distance, right? So that rho into H, that divided by, from this area it is coming out. So this is length L and then breadth is B. So that what I can write here? LB. Then R3 is equals to, R3 is coming from front to back. You just remember front to back. Front to back nothing but how much it is covering? Breadth B it is covering. So that only, that is rho B by, area is front area. Front area is L into H. So that L into H. Otherwise you can just remember as, whenever you know the length, automatically you will just write the remaining values, that's it. R1 is covering the length, okay, I know the rho L, and leave about the area, you just write the remaining values, that's it. B and then H. Whenever you see the R2, okay, R2 is going in this direction, so only it is covering the H distance. So rho H I will write. Then remaining the values you write as it is, LB. And then R3. R3 I have taken from front to back. Front to back nothing but it is covering how much distance? Breadth. So that B is finished. Then what is remaining? L and H only remaining. That remaining values only I have written here. Here L is finished, B and H are remaining. Here H is finished, L and B are remaining. Here B is finished, L and then H are remaining. Clear, right? That is the answer for the cuboid. And then cube, and then cylindrical wire of inner and outer radii of normal cylindrical wire. Copy everything. This one is the fourth body. Hey Nitish, good morning. My writing only is sleeping. Finished, huh? Look at this. This is a cuboid if I consider. This is a cuboid. Now what happening? Nothing but initial case R1. R1 is there like this. So this one is the length, and then this is the breadth, and then this is the height we have considered. Now R1 is coming out like this. Whenever the R1 is coming out like this, how much length it is covering? L length, rho L, divided by from which area it is covering? Which is coming out from H into B only. That's it, finished. Next one is R2. R2 is there in this direction vertically like this. How much distance it is covering? H, rho H divided by, coming out of which area? This area. This area is having length into, this one is what? Breadth for us, so that L into B. Next, R3 is just there like this, in and out. Now it is covering how much distance here? Breadth B, and then coming out of which area here? See that length L and then height H, L into H. Clear, right? Everything? Yes. Write the last problem and take the break. Two wires of same materials. Two wires of same material have their lengths in the ratio 2:3 and radii 8:9. Radii 8:9. Equal value of potential difference is applied. Equal value of potential difference is applied between their ends. Calculate the ratio of current passing through them. Find the ratio of resistances first. Then you will get the current automatically. Chalo, go for the break. Then I am leaving at 5 o'clock daily.